everyone, myself Kritika and my teammate Pravalika are going to present our presentation on the topic house price prediction using random forest linear regression and Gaussian boosting regression using machine learning. So this project is based on SEMA approach, which stands for Sample, Explore, Modify, Model and Access, and aims to predict the house price using different regression models. The original paper we referred to implement the random forest algorithm. However, in our research, we explored and compared alternative models, including linear regression, gradient boosting regressor, and found a significant improvement. We handling missing values using statistical method like mean median mode imputations, and detected and treated the missing values and outliers using IQR method, and scaled features using min-max scaler. In this modeling phase, we trained our data on multiple algorithms and evaluating them using mean absolute error, mean square error, root mean square error, and R square score. We conclude that gradient boosting regressor gave the most accurate result for predicting the house prices. So now we will go to the coding part. So in this project, as I mentioned before, we used a SEMA approach, which is a systematic data mining process developed by SAS. It provides a clear step-by-step methodology to handle data and apply machine learning effectively. So the first and foremost step is to explore and understand the data set. To begin with, we imported all the necessary Python libraries. For data handling and analysis, we used pandas and NumPy. For visualization and exploration, we used Seaborn and Matplotlib, which helped us to better understanding the distribution and relationship between the variables. So the next part is we read the housing dataset from a CSV file. This dataset includes multiple features of houses like crime rate, portion of residential land, distance to employment centers, and the target variable MIDV, which stands for median value of owner occupied homes. And the next step is to explore and visualize the data set. To explore the data, we started by viewing the first few rows using DF head, and then the last few rows by using DF tail, and then we randomly sampled a few rows to get more diverse look record by using DF sample. We also listed out the columns using DF columns, checked for missing values, and reviewed the data types to identify which column were numerical and which column were categorical. So here to start with the data structure, we plotted a histogram of the crime column, which shows the crime rate per capita, and that gave us an insight into how skewed a column could be. We also did for all the variables in the data set. And then we listed it out all the variables using DF columns, and we checked for the missing values using DF is null.sum, and then we checked for the variable types by using DF t types. And after doing this, the most important part is data pre-processing, which will handle mean values. So The next most important part is data cleaning and handling the missing values. We noticed several columns had a missing values, and we handled them based on the nature of the data. For uh, for normally distributed columns like features like crim and age, we used mean, and for skewed data like ZN and Indus, we used median, and for categorical data like CHAS, we used mod. After imputing, we checked again to ensure that all the missing values were handled properly or not. As you can see, there is no missing values in this column. So after treating the missing values, our next important step is to detecting and treating the outliers. The outliers can be distort the model's accuracy, especially in regression tasks. So we took time to analyze it carefully. First we selected all the numerical columns. Then we created a box plot for each numerical columns to visually identify the presence of outliers. This is the box plot. Here we can see what are all the variables has the outliers. And to quantify this, we used interquartile range IQR method. We calculated the lower and upper bound, and then filtered out the values beyond the bounds for each column. For an instant, we applied this model especially for the mid-B column and found several outliers. And there are two ways to identify handle the missing values. The first one is removal method, and the second one is capping method. In removal method, we will remove the column which has the highest outlier. So we remove the rows with the outliers for each numerical column, excluding the categorical column like CHAS, by applying the IQR boundaries. After filtering, we visually checked for the box plot again to confirm the reduction of the extreme values. And the next type is capping method. Instead of removing the data from the data set, in this method, we will repeat the outliers with the nearest acceptable values with the IQR range. And then we again box plotted to visualize the result and confirm the extreme values were now brought within a range without losing any data. So as you can see here, we are detecting the outliers. And it is before removing the outliers. These are the two methods. Method one is removal method, and the method two is capping method. Here you can see there is no outliers in any of the variable. So there is another method to view the outliers. We have seen here, we can visually see the outliers by using box plot. And the another method is we can view the outliers in a numerical form like this by using IQR method. And then there are two types in removing the outliers. One is removable method and another one is capping method. In removable method, we removed the rows with the outliers values in the each numerical column, excluding the column CHAS, by applying the IQR boundaries. After filtering, visually check the box plot again to confirm the reduction of the extreme values. And the another method is capping method. So instead of removing the data from the data set, in this method, we replaced the outliers with the nearest acceptable values. within a IQR range. So we again use the box plot uh, to visualize the result and confirm that the extreme values were brought within a range without losing any data. So once the dataset was cleaned by detecting the missing values and outliers, the next and foremost process is feature scaling. In feature scaling, we have used min-max scaler. So once the dataset is clean, we move to feature scaling. We have applied min-max scaling techniques using a scikit-learner's min-max scaler to normalize all the features between 0 and 1. In this step, it is especially important for a distance algorithm like uh, to verify that the transformation worked correctly, checking the minimum and the maximum value for the selected columns like RM. Here you can see the value is 0.0 and 0.099, which is closely to 1. And here we came to the correlation analysis. To conclude the data exploration phase, we created a correlation heat map. This visualization allowed us to identify which feature had a strongest correlation with the target variable. So, like for midweek, for instance, the feature like RM has the strongest positive correlation, while the latest, that is LSTAP, has the strongest negative correlation with the target variable. This step was a key feature in a feature selection and understanding the underlying pattern in the data.
Continue from where my friend stopped. She stopped at heat map. Heat maps are very excellent for visualization, and there is another way to see the correlations, that is in the numeric form. Here we are seeing in the numeric form for different variables like target variable, that is a median value, and for other variables also we are seeing here, and we are deleting the rad here. We are deleting rad variable here because it has lower correlation with median value and it does not affect the median value also. And we are printing this because to check whether the median value, the variable rad is deleted or not. If you see the output, there is no rad variable here, it is deleted. For checking we printed it. And for and next step is like for training and testing. Here we are doing it with 70 and 30. 70% is for training and 30% is for testing, and then we are checking the sizes. And the next step is splitting the data for random forest. Here we are importing the necessary libraries, and the random forest regressor we are used here because the model that is used because to predict the house prices, and the three metrics are mean absolute error, mean squared error, and r square score. And the next one we imported is train test split and numpy for computing the square root, and we are assuming the DFS data frame, and here the column is median value, that is a target variable, and we are splitting the data set into 70 and 30 and initializing and training the data. Here n estimators is equals to 500. That means that it builds 500 decision trees, and random state is equals to 42. It ensures that the split is reproducible and the result is consistent. Here and the next step is we are predicting on the test set and evaluating the model with four metrics here: mean absolute error and mean square error and root mean square error and r square score, and we are printing the evaluation metrics here. And next, if we see the output, we got the output for random forest regressor evaluation, and we did the cross validation fivefold cross validation we did here, and we defined the variables and targets, and then we trained the model, and we predicted the and we made the predictions here, and we stored those predictions in y prediction variable, and we evaluated the metrics, and we printed the outputs here. And the same we did for linear regression and gradient boosting regression also, the same, taking the same metrics and printing the metrics. And if we come for the comparison, we use the cross validation instead of train or test split, because it averages the result across all folds. So we use this cross validation, and when we split data into training or testing sets once, our results may depend too much on that split. So we use this cross validation. And if we come for the comparison, we have imported the necessary libraries like matplotlib, and we use that matplotlib because to plot the bar charts, and numpy library, and metrics for each model we have defined, and we have defined the values for metrics, that is probably from the output from the output of cross validation. And then we fixed the width, and we have given the bar plots, and we have annotated the bars, and the two tight layout and show. Here the tight layout shows that it will fit in the screen. The tight layout will ensure that everything neatly within the figure space, and the show method will display the plot. Here we can see the output here for model comparison using cross validation. And we here we can see the sky blue color for mean absolute error, and orange color for root mean square error, and r square is for green color. Here if we compare the three models, we got the best model as gradient boosting, because r square should be highest, that is 0.77. If we compare with these both models, we got the gradient boosting as a better model. And next step, we went for the pair plot. Pair plot will give us the pairwise relationship, and it helps to detect the correlations, outliers, and data spread. It is ideal for numeric data and exploratory data analysis, small to mid-sized data sets. And then we have did the correlation analysis, and we have described the correlation. By this we can conclude that we got the good model as the gradient boosting regression, and random forest also performed well if we compare with linear regression.
So, for the conclusion, this study evaluated the machine learning models for predicting the house prices using boost in housing dataset. While the original research used the random forest, we extended the analysis by testing the algorithms like linear regression and gradient boosting regressor. After through the pre-processing and performance evaluation, the GBR emerged as the best performing model with the lowest prediction error and the highest R square score. This suggests that the GBR is more accurate and effective approach. Future improvements could involve hyperparameter turning, deep learning models, or testing on larger data. So here we have taken the GBR predicts the most accurate value of the house prices with the difference of 0.3 value when we compare with the random forest. Thank you.
Thank you.